Ooh, ice lolly. Yum yum.
Hey,
Hello?
you left the freezer open.
Oh, sorry.
A few weeks ago, I was sitting at work when my phone buzzed. I got a push notification telling me that my kids had left the freezer door open at home. I immediately phoned them to close it, and let me tell you, their reaction to that knowing they left the door open from miles away was priceless. Why is it so hard for kids to close the freezer properly? For years, my kids would leave it open just a tiny bit, leaving me with a defrosted freezer, ruined food, and a massive puddle of water on the floor. Today, I'm going to show you how I used AI, some cheap electronics, and my 3D printer to build a custom smart sensor that sends notifications straight to my phone when the door is left open. And the best part? I did this using a £1 microcontroller. Having the freezer left open has been an issue for years. Before I built this, I tried everything. I tried patiently explaining, reminding them to double check every time they were on their way to take something out. I tried being stern when they left it open. I even bought an aftermarket alarm that beeps when the door is open. It was a complete waste of money. By the time the device started beeping, the kids were out of range, and I was the only one stuck listening to the desperate beeping every time I walked past the utility room. I needed a device that could actually send me a message to my phone. I have minimal experience with electronics, but since I've had so much success with AI to learn 3D modeling, I wondered if AI could teach me how to build a smart home tech from scratch. I started a conversation with Google Gemini to explore the feasibility of making a door reminder. I explained my problem and admitted that I was basically a beginner. At first, I focused on confirming what technical skills I need and which components would best fit my skills and budget. It is important that you feel comfortable to ask follow-up questions so you can also learn in the process. I even challenged Gemini with some of its recommendations. Once I got to the point where I felt comfortable with all the components, I ordered everything online and started a new chat to focus on the implementation. The brain of this project is an ESP32 C3 SuperMini microcontroller, which cost around £1 from AliExpress. I also picked up a breadboard, some resistors, and a magnetic switch. Gemini recommended some lithium AA batteries from Amazon for long battery life and easy maintenance. Now, electronics can seem intimidating. And to prove that point, I actually fried my very first microcontroller by mixing up two wires. Whoops! Luckily, for a project like this, the voltages are tiny, which makes it safe and parts are cheap. Fortunately, I anticipated making mistakes along the way, so I bought spares. With Gemini's help, I built the circuit in tiny stages so I wouldn't get overwhelmed. First, we got the software running on my PC, then connected the microcontroller to the breadboard and confirmed it works correctly. To program the microcontroller, I used Arduino IDE. Once you learn the basics and set it up correctly, it is very easy to use. Gemini made the whole learning curve and overcoming the technical obstacle a breeze. Then we started adding components one by one, and at each step validating that everything is working as expected. Gemini here also did a great job of helping me to troubleshoot the issues I encountered with the electronics components. The logic we programmed is actually really clever. When the door is closed, the device is completely asleep to save battery. When opened, it wakes up, checks the battery level, and if it's low, it connects to the Wi-Fi and sends me a low battery alert. Every time you open the door, it sounds a quick beep as a psychological reminder to close it. After 1 minute, it beeps again. After 2 minutes, it starts to beep more frequently. And if it's open for 5 minutes, it connects to Wi-Fi and sends me a notification straight to my phone. For the push notification, I used a service called Pushover. It is super easy to implement. has a free 30-day trial period and afterwards a $5 one-time fee for a lifetime access. Perfect for a home DIYer like myself. Once I got a working solution, I challenged Gemini with reducing the power consumption as much as possible. Then it suggested changing some resistors, disabling some features on the microcontroller, and even removing the power LED with a plier. Using a USB power meter, I was able to validate the power savings with each stage. It was very exciting. My goal was for the batteries to last at least a year. Once the circuit worked on the breadboard, it was time to make it permanent. I had some spare space under the plastic cover on top of the freezer, so I jumped into FreeCAD and designed a custom enclosure to fit into this space. To help me design the box to be as small as possible, I modeled the components and played around with the layout until I found the one I liked. Using these to design a box that perfectly fits around them was much easier thanks to each component being visible in the design. The battery holder and main board are both push-fit. For the board, I added these lips that allow it to pop into place with a satisfying click. I used double-sided tape for the buzzer to keep it in place and minimize vibrations. The space I was left with for the magnetic switch was tight enough so it didn't need additional fixing. I wanted it to be easy to maintain, so I designed a bracket that the main box just clicks into. I also gave it a simple, removable top instead of using screws, and hid the magnet switch perfectly on top of the door. Finally, I soldered components together using a prototyping board. Here, I had a wiring guy to help me, and I was triple checking everything to ensure I don't make mistakes. I slotted the components into the 3D printed box and installed it. I am over the moon with how this turned out. The only thing I would change is making the beeper a little louder, but since it texts me anyway, it really doesn't make a big difference. For others, I would also recommend using a slightly more expensive Seed Studio version of this microcontroller. That has an external antenna which will give you better Wi-Fi coverage. I have not been able to verify the battery life, but after 3 months of regular use, it is still going strong, so fingers crossed I will get to the 1-year milestone. I will leave an update in the description once I have further update on this. Thanks to AI, I went from throwing away defrosted food to building my own smart home tech. If you want to see how I started designing things using FreeCAD on day 1, check out my last video. Thanks for watching, and let's go make some awesome things.